FedEx. That's like actually. But she was, what are your top 3 choices? And I was like, I don't care. Whichever one I actually have time to do. But she was like, give me something to work with. She's like, whichever project you're on, you're going to be great with that. Thank you. She's working now.
You didn't have any like
It's okay.
I think the memes should get more esoteric because I have no idea what that means.
Well, you can see what's emerging infinity, like the money back. And then I think that's for tonight. So,
Oh, no, I see it. I
as
see
from
it.
tonight approaches zero.
Or super.
That's cool. She said, here you go for you guys, right?
I thought it was like sweater.
kind of scared.
Oh, I thought you said for you guys. Oh, I was like, oh my God.
I'm just not like it.
No, I'm serious. I didn't like that.
Oh, no, I did yesterday. Oh, right. But is it due today, or was it due late now?
It's due today. It's due today. I just started it a day early.
You don't have to.
You're your gym teacher. That's horrible.
Yeah, no, I had that the other day.
I know my one.
Wait, that was the couch. Why did
It's
you
like, what
say
the
that?
wicked did I do?
So high school.
Just fine with Joe.
I think he was the first time, but the ring.
I think the job would actually be
Oh
cool.
my gosh, that's crazy.
I mean, if that's what it is.
It's like $5 so like for Wednesday, Thursday, Friday. So that's their time. No free
My
time.
job isn't working.
And then Saturday, I was doing my homework.
Like, even if
And I
I
had
was
to go
rotating every one was
at night. The next one all day. And then I had to go home and go to sleep and then wake up until Monday morning. And then Monday night, last night was the first time I had any free time until 5 days.
I had like high
family for a year.
That'll be cool. It's not gonna happen.
So I picked up a copy of
Oh yeah.
I think he's still like, I don't know. I mean, obviously you should be at it.
I wonder if she counts off. Okay, good afternoon, guys. I would like your assignment 12 that I warned you about yesterday. So please make sure your name's on that and kind of get that to me so we can get started here. Most, if not all, of our class time today will be on assignment 14, so you should probably also find that in your binder.
But I didn't know if you wanted to see it or not.
I'm sorry.
I turned it in yesterday and you looked at it. I didn't know.
Oh no, if there's a grade on there, I don't need to
Thank
see
you.
it again. And change and levy your school business. Okay, any other assignment 12s? Okay, so again, most of our time today is going to be spent on assignment 14. Yesterday, again, it's hard for me to remember. I see y'all every day, so honestly, part of these agendas and stuff like this helps me remember what I need to do with each class. So it's a little harder on y'all, or harder for me with y'all. Yesterday, did I ask you to do at least half of assignment 14? I did do that, great. Okay, so part of what I'm going to ask you to do here in a few minutes is to work on finishing up assignment 14, and in just a second I will also start taking questions from assignment 14. So if you did at least half of it, you probably put eyes on some questions that you would be concerned about if they were on the test, so I will help out with that. Last call, any other assignment 12, last chance for full points, unless you're absent. Okay. So first thing I want to share with you, because I was going to come back and do this today in second period and then I forgot, So just some perspective, I don't know that it means a lot to you, but I already had typed up how last year's group did on this assessment. So again, ours is coming up Thursday, Friday. I'll have you do half of it Thursday, half of it Friday. So I had 3 AB classes last year. Overall, this first unit was about 84%, and then we gave it just a tiny bit of a curve, which made it to 90%. So, did I tell you what the curve was last year? Okay. So, the last couple years, what we have done is the test would have 22 points, but then we only graded out of 20. So, if you miss 2 points, you still make 100, if that makes sense. You get 2 freebies. Now, I can't promise that's what the curve's going to be this year, because part of it depends on how y'all do. If the averages before curve are 90%, then we're probably not going to curve it at all. If the average before curve is 70%, I don't know, we might give you 3 full points, 3 freebies or something. But also this year, Mr. Myrick's teaching the calculus class, so he gets a vote. Whereas last year I had all the calculus classes, so I could just kind of decide on my own. But in general, that's about what you should expect. Okay, so assignment 14 is the review, and the review has been structured to try to give you a couple practice questions of each type and hopefully help you identify some of your weaknesses. So the way I have this set up, or the way that I kind of think of this, is up here. I remind you, this is a skill you're probably going to have a question or 2 or 3 on your test about. Estimate a limit given a graph, or estimate a limit given a table. And then I give you a couple practice questions for you to try to make sure you understand what type of question I'm talking about. And of course, there's answers on the website to make sure that you're doing it correctly. And if you're missing a few of those, then you might need to put some more time to it if you want to be sure you get it right. And then I put this is completely optional, but I like to check off skills. So if I was you and I work these questions and I feel ready to go with that and you don't need to spend any time reviewing it, I tend to just put a check there, and that reminds me when I look back at this that I'm good with this section. And then maybe this section down here, maybe I struggle with that more, so I might wait to check it off after I study some more. Again, that's just a study tool, just a suggestion. So what I need you guys to start doing is, again, I want you to try to finish up assignment 14 the best that you can while you're in class, but I also want to start offering as much help as I can. So from the first page, which would be questions 1 through 5, are there any of those that you've tried, thought were harder, or your answers just didn't match up with the solutions on the website? Anything, questions 1 through 5, I can help on. Now, if you just skipped question 4, not because you think it's tough, but you just skipped it, you probably shouldn't ask that until you try it. So. Okay, then what about the first 2 pages? Questions 1 through 14. Which of those type of questions were you more concerned about? Yeah.
The estimating limits from the table from page 1. Is that just whenever the number becomes very large?
So that would be like the end behavior of the graph. So like this one that's trying to describe as x approaches negative infinity. Negative infinity. So that just means as x keeps getting smaller and smaller and smaller and smaller and smaller. So the far left of the graph. Whereas if it had said x approaches positive infinity, there's not one here, but that would describe the far right of the graph. Okay, what about the first 3 pages? Anything you've tried and are worried about? Yeah. Number 10. Okay, so here's where I can kind of split you guys into some different groups. Question 10. All right, if you also need help with question 10, then it would make sense for you to follow along with me and hopefully get some help out of this and maybe ask for some clarifying questions. If you haven't tried question 10 yet, I probably wouldn't follow along with me right now because it's easy to follow along with me and say, oh yeah, that's what I would do. But when it's you and you don't have any hints, you don't have anyone pushing you in the right direction, you may not. So if you've not done question 10 yet, but then you go home and you're finishing this up and then you do question 10, what you could do is you could pull up our class recording, jump to whatever, we're in 7 minutes into class, and then you can see me go over that, and then that would still help you. If you've already done question 10, you don't need to, and you checked it and you're good with it, you don't need to listen to me explain it again. I always am trying to make the best use of your time. So if that is you in the meantime, while I go over question 10, should just do a couple of your other questions. You don't have this assignment finished unless you did more than I asked you to, so just do a question or two that you haven't gotten to yet while you wait. Okay, so question 10 is about intermediate value theorem. Now, if I remember right, this is an actual AP exam question. So notice it doesn't say anything about, hey, this is intermediate value theorem. I kind of told you up here in the directions. That's intermediate value theorem. But intermediate value theorem was the one where if we know the starting y value and the ending y value, if it's continuous, whether it has no zigzag, a little bit of zigzag, a lot of back and forth, what IVT tells us is if it's continuous, it has to hit all of these y values at least once. So it could be multiple times if it switches back and forth between increasing and decreasing a lot. But even if it's just a straight line, you can see it hits all of the y values at least once. So when I'm reading question 10, these are x values, and so I'm curious, what is the starting y value? So if I plug in -2 into the function and solve, that would be -8 times 3 minus 10 minus 11. So -35, -45. Does that sound right?
Yeah.
So that's like the starting y value at the far left. The ending y value is going to be the y value when x is -1. So I can plug that in. Get -16 minus 3 would be -19. So if this starts at a y value of -45 and it ends at a y value of -19, did it ever have to be 0? No, it does not. It could be, but intermediate value theorem only guarantees it hits the y values between the starting y and the ending y. If this is the starting y and this is the ending y, IVT only guarantees I hit everything from -45 to -19 at least once. And this is asking about 0. So, not that one. So, unfortunately with this, we just kind of have to keep trying them until we figure out which one we need. So, starting y value would be -11. Ending y value would be 8 minus 11, which would be -3. So if you start at a y value of -11 and you're continuous to a y value of -3, did it ever have to be 0? What's wrong? Is it 10 minutes in? Yeah. Just read the top there to see how to sign out. What'd you say, yes or no? No. So don't pick B then. Okay. Some of this I can reuse. So I already thought about f of 0 in the last question. But f of -1 would be -3 minus 5 minus 11.
You did that.
Oh, I did. Yes, you're right. So starting y value is -19, ending y value is -11. Because this is continuous, IVT guarantees I hit all of those y values between that. but 0 is not between those two y values. So I have no guarantee that it will ever equal 0. So by process of elimination, if I'm pretty sure I did the first 3 correctly, it must be D. So if this was a real test, I would probably circle it, move on, and then hope that I had extra time to actually come back and test it. So this guy starts at -3. I did that so quickly because I've already done the arithmetic over here. He ends at a y value of 24 plus 10 would be 34 minus 11. Is that 33? Does that sound right? Huh? 23? Okay. Either way, doesn't matter. So, what about this tells you that this is correct?
0 is within that range, so it has to be at least a 1.0.
Right. So think about this graphically. The y value is negative, which means it's below the x-axis. Then the y value is positive, which is above the x-axis. So if this is continuous, it's got to equal 0 at least once. It had to cross the x-axis. So that's why D is correct. So again, it's not like I'm doing, the hardest thing I did there was arithmetic. The hardest thing I did was cubing some numbers. But you also kind of have to recognize that that is that type of question, and that might be the approach you need to take. Okay, was that enough there for that one? Okay, was anybody else going to ask about number 10? Have something more detailed about it? So if you guys have not figured out yet, I will always happy to take questions on stuff like this. The only thing that I am picky about, though, is I don't like to do the same question twice. So if you weren't ready for question 10 and help on it, that's fine. I understand, but please pick that up from the class recording. I'm not going to go over question 10 again just for you and hold the rest of the class back. So okay, so that's good for 10. Okay, somebody else pick another one on the first 3 pages. Anything you've tried that you thought was harder? Which word? Where's your assignment 14? Yeah. Do you know which parts of it you've done? Huh? Oh, you completed it. Okay, I'm sorry. There are a couple Khan Academy assignments you could get a start on if you wanted to. They're not due tomorrow, but if you already have this done and this isn't, I don't want this to be a waste of your time, so. Okay, I'm sorry, what was the question you had? Is it Liam?
It said 18.
18? Okay, so if you didn't need help with 10, that's okay, but tune back in with me for a second. Make sure you don't need help with 18. If you've tried this and you need help with it, this is your chance to get some help. Okay, determine if the function is continuous using the definition at the given x value. Now, even if this didn't say using the definition, that's understood. You shouldn't be guessing whether something's continuous or not without that definition. So you absolutely must know the 3-part definition of continuity. The limit from the left has to equal the limit from the right. So I will find those 2 things. And honestly, I hope that they're not the same, because then I can quit and say it's not continuous. If this works, though, I need to move on to the second part of the definition. Now, one thing that I think is kind of tough about this question, if I approach x, as x approaches -3 from the left, then x is smaller than -3, correct? Which one of these piecewise function is when x is less than -3? sorry. I just can't hear it well. Okay, because you only use the bottom one if x equals -3. You use the top one all the other times. Anytime x is not -3, like when you approach -3 from the left, because that's like -3.0001. That's not equal to -3, it's just close to -3. So I'm going to plug that in up here, and I'm going to get 0/0, which is the one that's a pain, but the most common way to deal with 0/0 is factoring, canceling, and trying direct substitution a second time. So when I plug in -3 into that, I get -6. So should I plug into the top of the piecewise function or the bottom of the piecewise function if I want to know a number slightly bigger than -3? And if I plug -3 into the top, just like I plugged -3 into the top over here, if I'm plugging the same number into the same thing, I'm going to get the same thing, right? So first part of the definition is checked. The limit from the left equals the limit from the right. Again, I just plugged -3 into the top both times. Okay, the second part of the definition, which I'll do in red, is our point needs to exist. So when x is -3, I need it to be something, not undefined, not existing, but when x equals -3, y equals 5. So, second part of the definition is good. And then the last part of the definition says that the limit, which I figured out from the first part, was -6, has to equal the point, which I figured out in part 2 is 5. And are these two things the same? Then those are not equal, so not continuous or discontinuous. Yeah, did you have a question about this or something else? Okay, yeah.
The second part, isn't it enough to just say that like g of -3 equals 5, or do you also have to put in it exists?
Just saying it equals 5 should be fine. Honestly, I think either one's fine, but alright, so I think this is what we focused on yesterday a lot. Limit from the left has to equals the limit from the right, part 1. The point has to exist, part 2. And the limit has to equal the point for part 3. All three things of those are true is continuous. If even one of those is messed up, it is discontinuous or not continuous. Okay, I don't remember who asked 18, but is that enough for 18? For everybody. Okay, then what next? Yeah.
This is just a general question.
Uh-huh.
Say
Uh-huh.
or is any type of answer, when you give your answer, is it y equals your answer or
It's not y equals, it would just be like, yeah, it's not, it's, I can't, my computer doesn't like 7th period either, I guess, but it's been a long day. If you have I'm just making up something, I can't see the question. If you have a limit, this is not the same thing as y, because y would represent like the y for a given x, if you're talking about a point. This is just equal to a number. So if you did some work and you got that the limit is 7, then the limit is 7. Don't say y equals 7. Y, it's approaching a y value of 7, but y actually isn't 7, so just be careful. Okay, go ahead and keep them coming, please. More questions you guys ask, the more I can try to help out. Yes, ma'am. Number 9, sure. In fact, I would say questions 6 through 9, to me, this is the hardest topic that we have to deal with in these first couple weeks. The indeterminate form, dealing with 0 over 0. Once you guys learn derivatives, which you will in a week or two, or at least basic stuff, I can show you something called L'Hopital's rule, and it gives you some options on how to do these. But in the meantime, you only know how to do them with algebra. So these questions, you always start with direct substitution, like this one. You plug it in, you get a number, that's your answer, and you get to quit. But like 7, 8, and 9, if you get 0 over 0, figuring out how to deal with that is really the first thing that everybody deals with in calculus. So we have to think of a way to make this look different, either this or this or this. And the unfortunate part is it can be anything. Anything you've ever learned is technically fair game. But the most common type, like number 7, is factoring. Another fairly common type, like number 8, is conjugates. And probably less common, but that doesn't mean that it's not fair game for the test, because it's fair game for the AP exam, would be question 9. And this is a complex fraction. Complex fractions are not unique to limits. You're going to need to simplify some complex fractions even in a week or two. But the first and most important step here, because if you don't know this first step, you're pretty much done. There's not any way for you to be creative here. Is you need to get this to not be a complex fraction. So what I mean by that is, I want this divided by 3 to go away, so I'm going to multiply by 3. I want this divided by 3 plus x to go away, so I'd like to multiply it by 3 plus x. Because you can undo divide with times. But if I only multiply this guy by 3, and I only multiply this guy by 3 plus x, really what I've done is I've just erased these small denominators. I've completely changed the question. The only way you can keep the question equivalent is if you multiply one thing by 3, every term gets multiplied by 3. If you multiply one term by 3 plus x, every term gets multiplied by 3 plus x. What I'm really doing there is I'm multiplying the top and the bottom by the smaller GCFs, and then on the top it's being distributed to these two terms. But since I'm multiplying the same thing over the same thing, I'm really just multiplying by 1, and we know multiplying by 1 doesn't change the size, it just changes the appearance. So one of the hardest thing about complex fractions, again, you just have to know that step. Multiply by all the small denominators to make them go away. But then the next hardest part is it gets pretty messy pretty quick. So these two canceled and left a 3 times 1. These two canceled and left a 1 times 3 plus x. And then none of these canceled because this x had a denominator of 1. And the way I wrote it is incorrect. So I just kind of skimmed past what a common mistake was there to help you see if you would catch it. Correct. This is negative 1 times 3 plus x. So I only made the 3 negative. I can't do that. I don't get to just make the first term negative. It's negative 1 times 3 and negative 1 times x. Either leave the parentheses or distribute. Now, I'm not finished with question 9, but I've made progress because I've gone from a complex fraction, small fractions within a big fraction, to at least it's not a complex fraction anymore. And after this, it's pretty easy. Plus 3 minus 3 goes to 0. Just combining like terms. The times x and the divided by x can cancel. And as soon as something cancels, now direct substitution probably will work out for us. So now I can plug 0 into what's left. Now notice, again, if you're not careful, you're going to lose something. The numerator still has a negative, so negative 1. When I plug 0 into the denominator, I get 3 times 3 plus 0, which would be 9. So negative 1/9. I don't need the limit anymore because I did your substitution there. So it's not like your test is going to have 5 of these, but you should not be surprised if your test has 1 or 2 of those. So make sure that you are prepared for that first step to give yourself a fighting chance. Okay, anything specific about 9 before I move on? Okay, anybody who has not asked a question yet today have one. I'll give you a chance before I give other people chances to ask multiples. And then we can just open it up to the last page as well. So anybody who has asked a question, even on the last page, first 3 pages or the last page, any of those you've tried yet that you want some help on? Yeah, 23. Okay, so again, just because you didn't need help on the last question, you might need help on this question. Make sure that you don't need help on 23 yet. Again, if you haven't tried it, you can watch this class recording later to see if you decide you do need help. And I think this is my 7th or 8th year teaching CalAV, and the first year or 2 that I taught it, Ms. Cross was also a calculus teacher, and this was the FRQ that we put on the test. So could be the same type of question. Obviously it's not going to be the exact same thing, but this used to be a test question for our first unit. Okay, so this is similar to what you guys practiced yesterday. A and B are just generic numbers. This is a polynomial, so he's continuous. This is a linear function. Linear functions are continuous. And this is a linear function. Linear functions are continuous. But just because each piece is continuous, if they don't connect right, then the graph as a whole is not continuous. Because again, you can have continuous, 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 but if these aren't connected and these aren't connecting, then your function as a whole is not continuous. So what I really need is these two to have the same y value when it stops being the top and starts being the middle. And I need these two to have the same y values when it stops being the middle and starts being the bottom. So all that to say, I need this and this to be equal during this time. So set that equal to that, and then we are going to plug in x equals 2. The reason why I need them to be the same at x equals 2 is because that's when it stops being the top function and starts being the middle function. So I temporarily plug in 2 for x. I don't know, I could combine some like terms, maybe add the b over, subtract some a's over. I don't know, but that's not going to be enough to finish the question. If your equation has 2 unknowns, that's not enough information to solve something. If you want to solve for 8 unknowns, you've got to have 8 equations. You've got to have the same number of equations as unknowns. But I've got this statement, so if I can ever figure out what A is, I can plug it in here and solve for B, or if I can ever figure out what B is, I can plug it in here and solve for A. That will be the easy part. Well, luckily we've got a little bit more information here, because it stops being the middle function and starts being the bottom function at x equals 5. And so if I need these two to connect, I want to set them equal to each other. And then I want to figure out what happens when x is 5. So temporarily plug 5 in for x. I don't know, combine some like terms, maybe subtract your a's over, and then you get a second statement. So over here, I know what a and b are in terms of each other, and over here I know what a and b are in terms of each other. So, trivia question, it's not calculus. What's it called when you have more than one unknown and more than one equation? Remember what that's called? There you go, system of equations. So, even as far back as Algebra 1, you probably did something called an elimination method or addition method, substitution, graphing. Do y'all do matrices in Algebra 2 now? Okay, so if you know how to type matrices in your calculator, you can get your calculator to solve systems of equations for you pretty easily. But realistically, in most higher math classes, we tend to rely on substitution. Substitution is the only one that always works. So basically, I'm going to go over here and say, this is what b is equal to. I'm going to plug it in, I'm going to substitute it in over here. And 2 times b would be 2 times this stuff. And then that gives me an equation I could solve for a. And as soon as I know what a is, I should be able to substitute that in here and or here. Shouldn't matter, I should get the same value for b. So if a is 2, b is 10 minus 7, which is 3. So there's the answer to the first part of that question. Now, I know you guys can do the algebra. You might be rusty on it, but I know you can do the algebra. That's not the important part here. The important part is understanding why I set these two equal to each other and plugged in 2 for x, and then why I set these two equal to each other and plugged in 5 for x. That's the understanding of why those need to connect and how we're algebraically making them connect. Now, as far as part B, the limit as x approaches 3, well, I would need the limit from the left to equal the limit from the right, but the top piece has nothing nowhere near close to 3. The bottom piece has nothing near close to 3, only the middle piece. So when I approach 3 from the left, like 2.99999, I'm going to plug it into the top. Except now I know what a and b are. And I'm going to get 2 times 3 plus 3, which is 9. And then I've got to do the right-hand limit. But the right-hand limit, as x approaches 3, would be like 3.0001, which still goes to the middle one. And if I plug the same number into the same thing, then I'm going to get the same value. So the second part of that question would be 9. Okay, so quite a few things going on there. Xavier, did you get what you needed from that? Okay. Anybody else going to ask about 23? Need something more specific than what I already have up there? Okay. Another question? Switch this over for just a second so I can talk about this. But we still got about 10 minutes, so please try to get a little bit more done. Where I need you to be tomorrow is I need you to try to finish up this assignment 14. So if there's still 1 or 2 more things that you decide you need help on, tomorrow's your last chance to ask one. So that's why I need you to try to finish assignment 14. I do have a couple Khan Academy assignments that I will assign to you. You're welcome to do them now if you want to, but I really wouldn't do them a lot of time. 14 is more important. Khan Academy assignments are actually pretty quick. So part of 0 over 0 factoring, that's probably the slowest one. But classifying discontinuities, figuring out if it's continuous at a point, and some infinite limits, those 3 all give you graphs. So those actually make those very quick questions because you have a visual to this. So again, you don't have to do those before tomorrow, but please try to finish 14, so if there is anything left that you need help from me on, I can actually help you with that tomorrow. And I promise not to keep saying this all year long, because drives me crazy too. But I want to remind you that our class website, where you've been going to check your answers, some things just have more resources than others. So, of course, you should be checking your answers to this stuff. It's kind of missing the point if you're doing it and making a lot of mistakes. But also, I just need you to be aware that last year, I didn't bother this year just because last year did so much. Last year, I had 3 AD classes. Between all 3 classes, these were the questions that they asked. So, if you get home tonight and you know that you need a lot of help with this question 29, click 29, it'll pull up the video of me going over that one question. So it's short, sweet, 2-3 minutes, sentence over. Or maybe I went over, I think we did number 10 in class together. Maybe we did that, but you'd like to hear it again, or you want to watch it slower and pause it and try to be more careful on this stuff. Anyway, those are already there for you to understand. That's right. They're required. But you don't have to do them before tomorrow. Tomorrow will just be me helping you finish up any last questions you had for 14, if you find any more, and the 4 time. Looks like I won't be able to get everybody's assignment 12 back to them today, because you guys had some questions, and that's fine. But tomorrow, when I get a chance to finish grading your homeworks, I will put them in your folder over there for you to pick up. And I want to say a couple days ago, the same thing happened. So if you didn't pick your homework up out of your folder, you might have a couple things waiting on you. And if you're not dying to get them back, then I guess you can wait. But for now, we got about 5 minutes, so finish up the question you're on. I know this agenda is for 2 days, so you might want to write down what you need to do. Make sure you do your best to finish assignment 14 so that I can quickly help you with anything you need help on tomorrow. That's your last chance to ask before the quiz. As far as puzzles go, I think I shared. Did I share the solution to the rat puzzle poison thing yesterday? Okay. Did I share a puzzle with you after that? No. Okay. Here's a new one for you to mess with if you're interested. And the yonder pouch magnet's up here if you need to unlock your stuff. This looks good. This one tends to trick smart people. Oh, I also really like today's theme.
So most meetings that I have are ones I found in past years and I just copy and paste. This is